Hello friends, welcome to this video on central limit theorem part 5. We have been doing problems on central limit theorem dealing with the two types of quantities x bar and Sn. This problem is about, we'll check what is it all about. If Vi, I equal to 1, 2 up to 20 are independent noise voltages received in an adder and V is the sum of the voltage received, find the probability that the total incoming voltage V exceeds 105 using central limit theorem. Assume that each of the random variables Vi is uniformly distributed over 0, 10. What we know about the central limit theorem? Central limit theorem deals with two types of problem. One is x bar, the other one is Sn. When you have searching for the problems on x bar, go for the keywords and search for quantities like average or mean. When the problem is on Sn, go and search for terms like total or sum. So now we will see what kind of problem is this problem posing on. Find the probability that the total incoming voltage of V exceeds 105. Total, which means it is going to be a problem on Sn. So we have now fixed that the problem deals with Sn. So what is our step number 1? To write the formula for Sn. So quickly recollect the formula required for Sn. What's the formula for Sn? We know that Sn follows normal distribution with mean n mu and standard deviation sigma into square root of n. What is our second step? Our second step is to find what are the data required for the computation which can be collected from the question. Now the first value is n. What is going to be the number of components taken for the consideration? We have been given I equal to 1, 2, 3 up to 20. So we are considering 20 noise voltage components. So n is equal to 20. Now the second and the third data required are mu and sigma. So how to get these two quantities? We will search if they have been given any words about mu and sigma. We have been said that each of the random variables Vi is following what distribution? Uniform distribution. Over what interval? 0, 10. Now, we know that f of x is equal to 1 divided by b minus a for a less than x less than b is the probability density function for your uniform distribution. Now, whenever my x varies between a to b, then f of x follows uniform distribution. And what do we know about the mean of the uniform distribution? Mean of the distribution is given by a plus b divided by 2. And what is the variance of the distribution? It is given by b minus a, the whole square divided by 12. So, we will be making use of these formulas to compute our mu and sigma. So, how can we go about estimating this? What is our interval? Our interval is 0, 10. In which case, what is the mean mu given by, this is my A, B. So, A is 0 plus 10 divided by 2. So, that makes it as 5. Now, about our variance. How is our variance denoted by sigma square? And how to get our sigma square? Sigma square is nothing but B. What is our B? 10 minus 0, the whole square divided by 12. So this is going to be 100 by 12. So now we know what is the value of mu. What is the value of mu? Mu is going to be equal to 5. What is the value of sigma? This is my sigma square. So when I take square root of it, I will have it as 10 divided by square root of 12. So the second step, the data requirement has been satisfied. Now moving on to the third step. What is our third step? Fix your data available in step number 2 in the formula available in the step number 1. So we know that Sn follows normal distribution with n mu. So it is 20 into 5. So this is my n mu, comma, what is my sigma? Sigma is 10 divided by square root of 12 into root over n. What is root over n? It is root over 20. So my Sn follows normal distribution with 100, comma. So this is going to be 10 root 20 divided by root over 12. So this is my step number 3. Step number 4. What is the step number 4? Identify the question requirement. What is the question requirement? The total incoming voltage V. Find the probability that the total incoming voltage V exceeds 105. So we have to check that the total incoming voltage V exceeds 105. The probability of this action. So we want probability of the total incoming voltage V exceeds. How to write exceed as greater than? What is the requirement? 105. So I want probability of V greater than 105. Now this problem is in V has to be converted to the problem of Z. How to go about it? So Z will be greater than your X minus, what is in place of my mu? In place of mu, I have 100. And what is in place of sigma? In place of sigma, I have 10 root 20 divided by root 12. So this will be the equivalent conversion from V to the normal distribution. Now substitute the value of X as 105. So the problem, which was V greater than 105, will now get converted as Z greater than. So what is the greater than? So we have it as 105 minus 100 divided by 10 into square root of 20 divided by square root of 12. Take out your calculators, estimate the data and arrive it to be equal to 0.3872. So I have this value of Z to be greater than 0.3872. So what is our next step? To identify it with the normal distribution. Draw the normal distribution graph. The normal distribution graph is a bell-shaped graph. So in the bell shape, I have the center line to represent Z is equal to 0. Now the required portion is varying from minus infinity to infinity, of which 0.3872. This is a positive number. So I can plot it to the positive region over here. So let me mark this as Z equal to 0.3872. So now what is our next requirement? Now I need the shade the region corresponding to it. What is the region corresponding? The region over here is given as greater than. Which is the portion which is greater than? This is my portion which is going to be greater than. So I will have to find the area of this shaded region which is happening over in the beyond region. Now you will have to recollect that the total area is 1 and half the area of your bell-shaped curve is going to be 0.5. Whenever we want the area greater than a region, then we remember the shortcut GST. Greater means subtract. So from where we will subtract? We will subtract it from, so Z greater than 0.3872 can be written as 0.5 minus probability of 0 less than Z less than 0.3872. So I will subtract this required value, which is going to be this required value can be got by subtracting the first portion, which is going to be from 0 to 0.3872 from my 0.5. Why do we do this? Because my table can read only from the center line to any given particular position. So we will be making use of the normal distribution table to find out what is this area of 0 to 0.3872 correspond to. Now round it off to 2 places of decimal because the data can read only 2 places of decimals. So you can write it as 0.39. So go check in your normal distribution table the value for 0 less than Z less than 0.39. 0.3 vertically and 9 in the horizontal position. Okay, 0.3. Where is our 0.3? Here is our 0.3, and where we want is 9, the second position. So the data is 0.1517. Okay, so we are going to compute this. So move on with 0.5 minus 0.39. 0.39 is 0.1517. Subtract it from 0.5. So the required answer can be obtained as 0.3483. Hence, we have found that the probability that the total voltage V exceeds 105 units is going to be equal to 0.3483 using your central limit theorem. Thank you.